Okay, guys, I'm going to be in class tomorrow, but I'm going to choose this method also, simply because the symposium's not working, and we're going to have to resort to this method as well. So I hope you had a great break, and we're going to get right to it. You should have already been working on Chapter 5, and you should have already reviewed the history of the development of the model of the atom, and we're going to use this method to discuss what the current model of the atom actually looks like, because it actually looks nothing like what you imagine that it might look like, or at least before last week. Now, the scale model that's shown there to your left is a jet fighter that's got wind blowing over it. Theoretical models of the atom have been developed over the last 100 years, and we're going to learn about the current one that's accepted. Please understand, no one has ever seen an actual atom with their own eyes, or even with the best telescopes that have ever been developed. We have not actually seen one. Only God alone has. So everything that we're going to talk about in this chapter is purely theoretical, based on experimentation and theory and mathematics. Nothing else. Please understand that going in. All right, I hope you understand that. Okay, and then we're not going to talk about that much, because we know that there were some problems with Rutherford's model, and it couldn't explain the properties of the elements, because we know that it's the electrons and how they're arranged in an atom. And see, Rutherford's model didn't account for those electrons. He said they're just kind of stuck. But we know that it's the electrons and how they're arranged in an atom that give an atom its chemical behavior. That's what this whole chapter is going to be about. All right? And if you really understand that, then our next chapter is going to be significantly easier for you. Okay? And he couldn't explain that too. And we're going to have most students' very most fun lab this chapter as well. So we know this. We've already covered this, and I'm not going to go over it again. All right. Development of the atom. And then here's what was Bohr's model, and we've already also talked about that, how he said that electrons are in this fixed energy levels and all those kinds of things, okay? And then like these rungs of a ladder, and I am going to spend a little bit of time on this, because here's one interesting thing that Bohr said, that the closer that they are to the nucleus, he said those energy levels are closer together, and the farther down they get, then the farther and farther apart they are. So this is something a little bit interesting, that they're not evenly spaced out like a regular ladder would be. So you need to be aware of that, okay? The higher the energy level, the less energy it takes to move an electron from one energy level to the next. All right, we're going to learn about that too. And then we're getting to the quantum mechanical model, which we've already talked about. We talked about Schrodinger and how everything that he is saying, again, that's what this chapter is going to be based on, what Schrodinger and others said. And he was a physicist, and he was also a mathematician. Everything that we talk about in this chapter is going to be based on his mathematics and his physics. Please understand that, okay? So you've seen a sine wave, I hope, by now, and know what that kind of looks like, that up and down, and that's what he said. And he's trying to describe what it comes from, okay? And he developed his own Schrodinger equation. So here we go. All right. This is a very interesting that I could never pretend to draw. One of the reasons why I chose this path. If you have this propeller blade, and it has the same probability of being anywhere, but you can't touch that blade and say, there's the blade, there's the blade, there's the blade. It just looks like a big blur. That's what they said about the electrons. Schrodinger said those electrons are moving so incredibly fast, there's no way to tell where they are. is like those propeller blades, and electrons are moving way faster than a propeller blade. You can't tell where they are at any time. They're a big old blur, because you actually on that engine can actually see the propeller blade. There's no way you can see an electron. It's moving too fast. The quantum mechanical model says there's no way that you can see where it is. It's going to just be a fuzzy cloud around the nucleus. And that cloud is more dense, where there's going to be a very high probability of finding an electron. He went on furthermore to say that that cloud was called an orbital. Okay? An orbital. And he proposed that there's going to be this region of space where there's going to be a very high probability of finding an electron. He called that region of space an atomic orbital. And he predicted what that path might look like, what that orbital shape might look like, that the electron, the path that electron might take, based on the path that he thought, just like a propeller, is fixed in space. It's tied to that airplane prop on that. The propeller is tied to that airplane. It can't move from that place. Well, an electron's not tied to anything. Okay, it wants to hang around those protons, because its ultimate goal will be to get together with one of those protons. So it's going to hang around that nucleus as much as it can, but it's not tied there like a propeller is tied to the airplane. So it can change its shape. It can move from its path, but it's going to move in a predictable path. That's what Schrodinger said. Okay, and each energy sublevel has this different shape, where there's going to be a high probability that's going to be found. And these are the shapes he predicted that these electrons are going to take. There's s orbitals. In s orbitals, you can think about them as being S-shaped or sphere-shaped, like a sphere, S for sphere. And then P-shaped. And there are 3 of these P orbitals. And I'm going to show you more, I hope in person, what these P, they kind of, you have to think about them being on top of each other, like your pencils, like making a cross with pencils. But P, I think of P as peanuts. They look like peanuts to me. So P for peanut. And these are, remember, shapes that electrons make when they're flying through the air. Think about that, okay? And then you have D orbitals, D-shaped. D for dumbbell shapes or donut shapes. They sort of look like donuts, especially that one on the end that's got the donut around the outside of it. All right? Again, these are shapes that electrons are making as they're flying around the nucleus of an atom. So it's very hard to wrap your mind around. We're going to talk about it in class. All right? So let's talk about what it means as far as that goes. These electrons, how they're arranged in an atom, is what gives it its chemical behavior. And we're going to learn to write what's called their address. Okay? That address is called its electron configuration, which we're going to learn about it. And I'm going to see you, I hope, tomorrow.